Hi, my name is Akash and I am MTech graduate from IIT Kanpur. Today I am trying something new. This is my first video on machine learning, and when anybody talks about machine learning, the first algorithm that comes to in mind is linear regression. So this is my first video, so let's get started. If we look at the term linear regression, there are two terms in it. First is linear and second is regression. So let's understand both of them clearly. What linear means? Linear is something like a straight line relationship. That means as one variable changes, other variable also changes in straight line, whether it's increasing or decreasing. For example, if we consider our studies, which might increase marks obtained by students roughly in the straight line. So linear simply means that we are trying to represent the relationship using straight line. Now comes to the second part, regression. Regression is a concept in machine learning where we predict continuous values. For example, predicting marks, predicting house prices, predicting temperatures. So all of these values are continuous in nature. We are not predicting categorical values. Categorical values are kind of blood groups, grades of students, grades in the sense A plus, etc. So these are the categorical values. We are not trying to predict categorical values. We are trying to predict the continuous values. So this is called as regression. So combining both ideas, linear regression means predicting continuous values using straight line relationship. Now let's understand with the data. Suppose we have a data of house prices, area of the house and price of the house. At this point we can all agree that if area increases, house price can also increase in roughly straight line manner. So they can be x1, x2, x3, x4. They can be y1, y2, y3 and y4. Now let's try to visualize these values. So there can be multiple factors. So this is x, this is y. Now x1 y1 can be here, x2 y2 can be somewhere here, x3 y3 can be somewhere here, and x4 y4 can be somewhere here. Now when we look at these points, these are scattered, these are not completely in the straight line. Now if we try to draw any line between them, this can be this line, or it can be this line, or it can be this line as well. So how do we know that which line is best? Because none of these lines are passing through all the points correctly. This is the real world problem, because in real world data is not in the straight line, always in the straight line. There is always some noise. So it can be where this house is situated, I mean its locality or the material that is used or how old the house is, and depending on all such factors, price of the house also changes. Now we have to find the best fitting line. But how do we find the best fitting line among all of these lines? So there are three lines, and how do we find the best line among these? So what we do is, let's remove the lines first. Now as we know, some of the lines were pretty bad, so I have removed this, but we need to understand why this is the best fitting line. So now considering this line, for every data point there is this predicted value. So for this line at this value of x, the predictive value of y is this. So this is y cap and this is actually y. So this is y1 and this is y1 cap. So this is the predicted value. Y1 is what? Actual value. Now let's calculate the difference between them. So this y1 minus y1 cap is something, the difference between the actual value and the predicted value, right? Now, similarly for x2 as well, there is the predicted value is here, y2, and this is the actual value, y2. And for x3, the predicted value is y3 and actual value is something here. And similarly it goes for y4 as well. So predicted value is here, y4, and this is the actual value. Now the straight line difference between all of these are the errors, right? The errors what we calculate is y1 y2 minus y2 cap plus y3 minus y3 cap plus y4 minus y4 cap. But the problem in this equation is here y1 is greater and y1 cap is smaller. The value of this is positive. In the second term, y2 is smaller and y2 cap is bigger. So this becomes negative. But positive and negative cancels each other, but this should not cancel because the difference is always there. So we should not take the actual values of the differences. Instead, what we try to do is we can do the modulus of it. So this might be yi minus yi cap. This will be summation from I is equal to 1 to n, considering there are n points. This value gives the absolute difference between the actual value of y versus the predicted value of I. If we take the modulus of it and take the summation of all the terms, it will give the entire error. This is called as absolute error. Now our goal is to minimize this error. Why do we minimize this error? Because if we minimize this error, then only we can say that the line passing through it is the best fitting line. However, in machine learning, the absolute error, I mean the modulus function, so this modulus function having graph like this. So at this point, it's not differentiable. Generally, we can use this absolute error, or we can use something called as squared error. What is squared error? The squared error is something like yi minus yi cap. So square of this term, summation I is equal to 1 to n. Now y square, because we want to penalize the large distance. So our goal became summation of I is equal to 1 to n. So if there are n points, yi minus yi cap square of this. So this equation becomes our function and we need to minimize this. But what is yi cap? How do we predict what is yi cap? So yi cap, as you can see, yi cap are these points. So these points are on the line. So given the value of xi, we can determine the value of yi cap by putting the value of xi in the equation. Equation of the straight line is mx plus c, right? So here m is slope and c is intercept. Here the yi cap becomes value of m xi plus c. So we need to find the equation of this straight line. It means we are finding values of m and c such that this error we found here should be minimized. So the goal of linear regression becomes, so f is a function of m and c, right? Arg min m comma c, and this is the function. This function is called as error function. So what is mean by this argmin here? So argmin, generally we write min. Min means taking the minimum value, and here arg means find the values of arguments m and c such that this function is minimized. So here our goal becomes argmin of m comma c, and we can substitute this error function here. So this error function becomes summation of I is equal to 1 to n yi minus m xi plus c whole square. Now there is a algorithm called as gradient descent. What it does, it takes the random value of m and random value of c and it iterates multiple times such that it will find the minimum value of this function. So this is the function of m and c. So it will take the random value of m and c and it will calculate the value of m. Then it will adjust the value of m and c and it will again calculate the value of n. So iteratively it finds the multiple values of this function and it will iterate until it reaches the minimum point. So this minimum point is where this function, the value of this function will be minimized, and which means that we are getting the optimal values of m and c. So this work is done by gradient descent. So there are other terms for less polynomial regression. What it means is, here we considered price is dependent on only one factor, that is area. So here x1 was area and y1 was price. But there can be multiple such factors on which the price can be dependent on. Another factor can be age of this property or the locality of the property. So there can be many factors. So this can be x2, this can be x3. So multiple such x involved in it. So this function is not a straight line in just two dimensions only. Currently it is only two dimensions because there are only first dimension is x and second dimension is y. But there can be multiple dimensions. If we consider age of the property, so this can be represented as this x1 as the area, x2 as the age, and this value can be price. As we can only visualize till third dimension for human eyes, I'm only drawing only three dimensions, but there can be multiple such dimensions, and the straight line can be in the multiple such dimensions as well. So this is called as polynomial regression, which I will explain in next video. So this is my first video, so bear with all the problems that occurred during the video, but I hope you understand what linear regression is. So linear regression is actually a very depth concept. So it's the first algorithm, but for new enthusiasts, it should not be too complex. So I kept it very subtle and very minimal explanation. I hope you enjoyed the video. If you enjoyed, please like and share. Thank you.